everybody. I am honored to be here to speak to you at Laracon. There's a lot of people here. This is totally awesome. I ask it if you want to tweet about anything that I'm talking about today, to use both the AWS and the Laracon hashtags. That way I can prove to my coworkers and my boss that I was actually here and not walking around Times Square. So I did want to introduce myself a little bit because there's probably a lot of you that don't know who I am at all. My name's Jeremy, or JeremyMI on Twitter, and I really love PHP. I think PHP is awesome, for better or for worse. I live in Seattle, where I am one of the co-organizers of the Seattle PHP user group. And you can follow us on Twitter there if you want to. And like Taylor said, I work for Amazon Web Services, and I work primarily on the AWS SDK for PHP. I'm curious, I'd like to see a show of hands of anyone who is already using the SDK. That's awesome. What about AWS in general? Even more. That's awesome too. Cool. So you guys are already going to be familiar with some of the things I talk about today. If you are not following AWS for PHP on Twitter, that is the official Twitter account for the PHP SDK and other PHP-related AWS things. So we tweet about releases, we tweet about blog posts, and other related things. So that's AWS for PHP, again. And I think also another important thing to know about me is that I really like to make funny faces. And believe it or not, this actually comes into play later in the presentation. So I don't consider myself a Laravel user. I don't work on applications right now, so I don't really have the chance to use any kind of framework. But I do consider myself a Laravel contributor. And that's not because I made a couple of minor pull requests, but it's because of some of the other software I've worked on. So if you do a composer installation of Laravel, you actually end up with some of my code in there by default. You might not be using it, but maybe you are. So that the AWS SDK is one of those things that comes into Laravel, and that's part of the SQS driver implementation. It uses the SDK to work with SQS. I also, along with the SDK, I maintain the Laravel service provider for the AWS SDK. So if you're using AWS and the SDK, and you're not using the Laravel provider, you might want to check into that. It's basically just a really thin layer that puts the SDK in your container and hooks up a facade to it. Well, I'll show you that actually a little bit later. And then, like Taylor said, I also maintain the super closure library, which is the scariest piece of PHP code I think I've ever written. And but it is pretty cool. So if you're doing things like pushing closures onto your queues, super closure is the code that actually serializes the closure, something that's not normally possible in PHP, and it allows you to do that. I think one of my most interesting contributions to the Laravel community was something I did by accident. Earlier this year, I made a joke about there not being a Laravel drama Twitter account, and then someone made one. So sorry about that. Hopefully he does not cause too much trouble for you. So today, I'm here to talk about the cloud. And I don't mean, the clouds that you see outside. It's kind of cloudy today. I'm from Seattle, where it's cloudy pretty much every day of the year. So I'm not talking about those clouds. But just to be more accurate, the clouds in Seattle actually look more like this. That's basically what I see every day. I'm here to talk specifically about the Amazon Web Services cloud, which coincidentally also comes from Seattle, but that's not particularly relevant. We've been talking about the cloud for several years now. And when we first started talking about the cloud, I logged into the internet. There we go. Whoops. When we first started talking about the cloud, someone would say, the cloud, and then everyone else would kind of get, the cloud. And the cloud was this buzzword that everyone was talking about. No one really understood. And, everyone's like, oh, the cloud, yeah, that'll probably go in a few years. Well, I'm here to tell you that it's not going away. And it's not even a buzzword anymore. And if you don't know about the cloud, you need to learn about it. And so that's part of the reason why I'm here. So when we talk about the cloud, we're of course talking about the term cloud computing. And this is probably the best definition of cloud computing that I've seen. The term cloud computing refers to the on-demand delivery of IT resources via the internet with pay-as-you-go pricing. It means that you can get the computing resources you need when you need it and only pay for what you're actually using. Now, I have the term IT resources highlighted there, and that seems kind of like a generic term right there, so let's talk about that a little bit. What do you think IT resources are? Give me some words here. Servers. Databases. Storage. What was over here? Bandwidth. Okay. Developers. That might work. What's that? CDNs? Yep. So I made a little list too. This is still only a few things. Some of the things you said are right on there. Servers, computing or working nodes, distributed queues, databases, push notifications, file storage, load balancers, CDNs, cache clusters, and many, many, many more things. IT resources is like the most generic thing you could say to a programmer. So these things and many more are things that Amazon Web Services provides to you. And they do it through their web services by providing APIs that you can actually create and control these IT resources through your programs and scripts. And so let's take a look at how you would provision a web server from your PHP code using the AWS SDK for PHP. And that's talking to the Amazon EC2 service. The code for that's pretty easy to get the basic thing running. So first we got our autoloader that we're loading from Composer. So that the SDK is installed through Composer, so you can use the Composer autoloader. Then we have to create an instance of the EC2 client. We give it a region because AWS has data centers in many places in the world. And we specify a region so that we're creating the servers where we want them to be. Now, if you're using that Laravel service provider that I told you about earlier, that becomes a lot easier because you can just use the facade class. And then let's take a look at this method. So we are calling run instances method on this EC2 client. The way that the SDK works is that for each web service client, it's got methods on it that correspond one-to-one with the APIs provided by the service. So there is a run instances operation in the EC2 service. So we call the run instances method. We pass in an array of parameters. So basically you have an image ID, which has got a funky code right there. An image ID is basically what you're going to put on that virtual server. It's just like any kind of other image that you'd use with like VMware or VirtualBox. But the AMIs, the Amazon Machine Images, are the format used by Amazon Web Services. And you can actually, using EC2 service, you can convert between AMIs and other formats like for VirtualBox and back again using some of the tools there. So we're using this image, which is actually a PHP 5.5 LAMP stack. Then we're saying we want one and exactly one web server created with those min and max count parameters. And then the instance type refers to like the specs of the machine. So we have different types of machines. The M1 small is one of the smaller ones. But you can use some of the different kinds. There's well-rounded machines. There's some that have really high storage, really high RAM, really high CPU. You basically can choose what fits the workflow of your application or what you're doing the best. So what does that do? Okay, I'm turning off internet here. There we go. All right, hopefully that won't pop up again. So what does this do? Well, this provisions a web server for us. But if you tweak those parameters a little bit, you can get more web servers if you want. So right there from your PHP code, that short code, you can provision web servers for you very easily just with that one command. And you can use even more parameters to add things like storage volumes and configure key pairs, static IPs, firewalls. And these are all things that are a part of the Amazon EC2 web service. Now we have lots of other web services a part of AWS as well. Things like Amazon S3 for file storage or static site hosting. We have things like Amazon RDS for relational databases. RDS supports MySQL, Postgres, Microsoft SQL, and Oracle, and allows you to do cool things like read replicas and master-slave setups. It's also things like Amazon SQS, which is a distributed queue system. And other things like Elastic Transcoder. This is actually a service that allows you to transcode video and audio. So you could make your own YouTube if you really wanted to, without having to do all the legwork of figuring out how to mess with video and audio. And right here is the full list of the services that we offer right now. There's a lot. I'm not going to talk about all those. You can look those up on your own, I think. Along with these services, we provide tools that allow you to interact with the various APIs. So among those is the PHP SDK, which I work on. But we also produce SDKs for other languages like Java, Python, .NET, Ruby. We recently added a browser JavaScript one that uses cores to talk to some of the Amazon Web Services. So you can actually talk directly to AWS from a client-side JavaScript application. There's Node.js, iOS and Android SDKs as well. Then there's also things for, we have a really great CLI tool that's still, I think it's still in beta, but it's getting close to release time. But it's available now, you can use it. Things for Visual Studio, Eclipse, PowerShell. Then of course there's our online management console. And we even have an iOS app that you can check on your servers and execute commands from your phone. So a lot of this stuff is open source projects. So if you go to GitHub/AWS, you can see all the things that we're working on there. AWS has hundreds of thousands of customers all across the world. And I don't put this up here to brag. I don't put it up here to sell you anything. I just want you to know that there's people in businesses that have put their trust in AWS, and they're doing really awesome stuff using the cloud. So if you haven't considered using AWS, or you're wondering, what's so good about it, just take a look at some of the names up here, and maybe it'll inspire you to at least check it out and see how it can help you or your business. So let's go ahead and build something. I told you the funny faces thing was coming back. So we're going to build a little app called the Funny Face app, where you can upload funny faces. It's only going to have 2 pages. It's got the page that shows you the funny faces, and then a little form to upload one and add a caption. We're going to do this using the AWS SDK and Laravel, and we're going to deploy it to the cloud. All right, so part 1, we need to set up our dependencies for this project. So first thing I did, and again, I'm pretty much a Laravel noob. This is the first time that I've actually sat down and wrote a Laravel application from end to end. I've used the components before, but not all together for an application. So I followed the Laravel Quick Start Guide in the documentation and set that up. First thing I did after that is went over to my Composer JSON and added the AWS SDK and the Laravel service provider. And after, sometimes Composer takes a few minutes to install everything. After that was done, I went over to my app config, and I added the provider to the providers list. I added the facade from the service locator to the aliases list, so that was all hooked up. And the next thing I did after that is I set up my AWS credentials. So, and actually, a new feature in the latest version of the SDK is the ability to use a credentials file that's separate from your application and just lives in your home directory. That's something we added recently to help people manage their credentials better and not accidentally commit them to their GitHub repository or something like that. Yay! Because we don't want you to do that, and I'm sure you don't want you to do that because, things cost money, right? So we have this separate file that you can use. It's basically just an INI formatted file. And what's cool about this is that this file is going to be used by other AWS tools like the CLI and other SDKs. So this file will actually work across tooling with some of the other AWS tools. So you put your credentials in there. You can use multiple credential sets, but here I'm just using default because if you don't specify a profile when you instantiate the SDK, then it'll just use the default. And so we'll just rely on that. And so to set up my application, there's a couple of AWS resources that I needed to set up, including an S3 bucket and a DynamoDB table. S3 is, of course, our file storage service. So an S3 bucket is where I'm going to put all the pictures that get uploaded, so I can keep those and show those on the website. Amazon DynamoDB is a NoSQL database service provided by AWS. That's pretty simple. You basically have a key, and then you have a bunch of other data associated with that key. And it's not relational at all. It's a NoSQL database, and it's really easy to just throw things in there. And since it's a simple app, I decided to just, instead of setting up MySQL and creating schemas, I just wanted to do something that was really easy, and DynamoDB suited that pretty well. I wrote a artisan command to help me get things set up. So, because that's the way to do it, right? Use artisan to do everything that makes it nice and easy. I thought so. So I'll show you what some of the artisan command stuff looks like here. So I won't show you the skeleton of the command because that's just kind of boilerplate stuff, but I have the methods actually interface with the SDK here. So there, I created one called createBucket, which does a few things. First, it uses a helper method in the SDK to check if the bucket exists. If it already exists, then I don't need to create it. And one thing I did want to point out is, here we go. With this, I'm not using any parameters because I have it randomly generate a bucket and table name. If you don't provide one, you can with the command that I did. And I'll post the code for this application after I clean it up a little bit more. I'm going to open source it, so I'm linked to that from my slides later. OK, so I check if the bucket exists. And then, whoops, yeah, there we go. I create the bucket. So this is similar to how that EC2 run instance command worked. Again, this is calling the methods that map one-to-one with the API. So calling the create bucket operation on S3 and passing the parameters here, which is just the bucket name, the thing I want to call it. And there's a lot of operations in AWS that are asynchronous in nature. So like when you call EC2 run instances, like we did earlier, that's going to immediately return back to you and say, all right, we're creating those instances. But it doesn't mean those instances are available right away. And the same thing goes with buckets. Though buckets tend to be created very fast, the SDK does have a concept called waiters, which allow you to basically wait and pause in your script until a resource is available for you. So after I create the bucket, I wait until the bucket exists. And it'll just sit there until it's ready. And like I said, with buckets, it's really fast. And I think most of the time, it doesn't have to do any waiting. But just in case, I have it there so when I want to use that bucket, I know it's available. Those waiters are a cool feature in the SDK. Like I said, they wait until some kind of resource is in a particular state. So with the S3 bucket exists, I was waiting till the bucket exists. Makes sense. And they're really great for handling asynchronous operations, and they're pretty easy to use. Like this is one for DynamoDB waiting for a table to exist. And depending on how much bandwidth you want your table to have, it can take longer to create. But it's usually pretty quick. But again, if you're creating a table and then immediately describing or updating the table, you want to make sure that table exists, or else you're going to get an exception back from the service. The other part of the command that I had to set up the application was for creating the table. So you see I'm using that waiter to creating the table and then waiting until it exists. And everything at that point is ready for me to actually use. And you'll see here I have a ... there on the create table command because specifying the actual table arguments couldn't fit on this one slide, so it's right here. So when you create a DynamoDB table, there is no schema, but you do have to specify the keys and how those work and what types those are. So this is the code to do that. You have to define what the names of those fields are and what type they are using the attribute definitions, and then use the key schema argument to describe what part of the key they are, either the hash part of the key or the range key. So you can have both of those types. And then the way that DynamoDB works is kind of cool. Instead of, you can basically set up a DynamoDB table to scale to however much you want to use it. So if you're going to do 5 requests per second or 500 or 5,000 requests per second, you can do that with DynamoDB. You just need to provision that amount of throughput for your table. You tell AWS, hey, I'm going to be using this table this much, and they provision the hardware for that database under the hood for you. So that's what the provision throughput is. I made a really small table, but you can make much bigger tables to handle more traffic. All right, so let's build our application logic for this code. So first, I started with the page that shows the funny faces. I wrote a simple route there, and I have highlighted app make funny faces latest. So I have a special class called funny faces I can show you the code for here. But the rest of the route is really simple. I'm just getting the data and throwing it out to my template. So to work with DynamoDB to get the funny faces, I'm using the DynamoDB client again, and I'm using the query operation. And I use the query operation to get back, I'm using the query operation to get back funny faces, and the query operation allows you to specify the order. So that's what that scan index forward false means. That's why I want things in the kind of the last in, first out order. So I want to show them the newest at the top and the oldest at the bottom. So one thing I'm doing differently here is instead of just calling the query method, I'm using getIteratorQuery. Iterators are another concept in the SDK that are a special one. So a lot of operations, both in AWS and other web services, are paginated. And in order to get like a full set of results, you have to make multiple requests to get all those. And with DynamoDB, it's the same way. So if you have lots of items in your table, you can only get up to a certain amount. I think it's a megabyte of data at a time. And if you have more than that, then it sends you back a token that you have to use in a subsequent request to get more of the data. Now, I've written the code to do that and make multiple requests. I've done it several times, and I hate doing that. It's really annoying, because you have to create this loop and make sure to get the token, check if it actually gives back a token, then feed it back into the next item in the loop, except the first time you run the command, there is no token at all, and so you have to account for that, and it ends up being kind of messy. So when we wrote the version 2 of the SDK, we added this concept of iterators that make it super easy to work with those paginated results, because all you do is create the iterator for it, and then it does all the pagination for you in the background. So you don't have to worry about the tokens. You can just create the iterator and then do a for each loop and do whatever you want with the data. And it will make the requests that you need to get more data in the background without you worrying about it. The other cool thing is that the iterators are compatible with all the SPL iterator classes, so you can decorate the iterators returned by the SDK with the SPL iterator classes if you want to. Okay, so for the upload page, again, that's a really simple route, especially for the get aspect. It's just displaying the form, so nothing special there. For the post, handling the form, this is the code for that. Basically checking the items that got submitted, make sure that I have a caption and the photo. And then I'm calling out to that special class that I made again, and then redirecting based on what happens. So for handling the upload, I'm going to use both the S3 and DynamoDB clients because I need to actually take my image, I'm going to put it in S3, and then create a record for that image with the caption. So first, using the S3 client, I call the put object operation, and I tell it which bucket, I tell it the key, which I'm getting from the file name that was uploaded. Then I pass in the body that I'm uploading. So what's cool with SDK is you can specify the body as a string, but you can also use a file handle. So I'm just doing that, and that makes it a little bit more efficient to work with. And then since these images are being displayed publicly, I set the ACL so that it's public read by default. And then the result of that operation, I get the URL from it, so I can save that into the DynamoDB table. And this is using the put item operation. Let's give it the table name, then I give it the data about the item. The way that I did this is so I could do the sort ordering. I have an app field that I just put a hash in that's unique to my app, and then put in the timestamp, which I use to sort by. And then I put in the image source and the caption, and that's it. So pretty easy to upload things into DynamoDB. And with Dynamo, you see like these S and N fields. That's the type, either string or number. Dynamo requires that information because of the way that they store it, and they give it back to you in the same type. What I didn't show is there's actually a method in the SDK that you can just give it just a normal key value array, and it'll figure out the types for you and reformat it. But I didn't show that in this example. All right, so that's basically the whole app. Pretty simple, and it was pretty fun to write. Thanks, Taylor. So now we're going to deploy it to the cloud. So far we've used 2 services. We've used S3 for storing our files. We use DynamoDB for storing the information. We're going to go ahead and use 2 more services related to the way that we're going to deploy this application. We're going to deploy it using AWS Elastic Beanstalk. Who here has heard of that or used it before? OK, cool. So I think Elastic Beanstalk is a pretty easy way to deploy your application in a scalable way. And what it does for you is it actually takes advantage of some of the other AWS services that already exist, so like EC2, Elastic Load Balancer, and auto scaling. And when you upload your application, it will deploy it to an environment on EC2 that's load balanced and auto scaled automatically. So you don't have to worry about configuring all that stuff. So if it's like your first time working with the cloud, working with AWS, Elastic Beanstalk is a really good way to get started, because it can manage that infrastructure for you. And then as you progress into other things, Elastic Beanstalk may still work fine, but if you find yourself making more customizations to your architecture, you can then use those auto scaling and load balancing services outside of Elastic Beanstalk as well. Or switch to one of our other services like CloudFormation, which gives you even finer grained control over your application's environment. So the other service, AWS Identity and Access Management, allows you to control how your AWS resources are used. And we're going to use that to help provide our AWS credentials to the Elastic Beanstalk environment without us having to upload our credentials anywhere. We're going to let Amazon handle the credentials for us. That's a much more secure way of doing it instead of us trying to like SCP a credentials file to a server. We don't want to do that. So IAM allows us to get our credentials into our environment very easily. To do that, we create an IAM role, which is basically a named set of permissions for our resources. And then we associate that role with our Beanstalk application when we deploy it. And then the credentials will be available on our machine. And the SDK will automatically pick those up and use them without any thinking on your part, which is kind of cool. Elastic Beanstalk provides a command line tool called EB. And you can use that to set up your application to be deployed in Elastic Beanstalk. If you, once you install the tool, which I believe requires Python, you can run EB init. It'll ask you a few questions, set up your application by creating a folder in your application that it automatically adds to your git-ignore file that contains the information that Elastic Beanstalk needs. And then when you do EB start, it'll actually create your environment. The first time you do that, it takes a few minutes, like 5 to 10 minutes, depending on your configuration. But once you have that, you can, every time you modify your code, you can do git aws.push, and it'll deploy new versions of your application pretty quickly to your Elastic Beanstalk environment. But the EB CLI tool isn't the only way to work with Elastic Beanstalk. There's also the management console. You can go on and just upload a zip of your application if you want to do it that way. Or you can use the Elastic Beanstalk API, which I think the other two options are much easier than using the API, because the API actually takes 3 calls to get set up with everything. Now, for when I was working on this application, I was trying to deploy it to my Beanstalk environment, and I actually had a little trouble with that. Who's had a little trouble with their Elastic Beanstalk environment before? So what was happening is that the Composer installation was failing. One cool thing about Elastic Beanstalk is that it will run Composer for you, so you don't have to include your vendor folder when you upload your application. It'll run it for you. But just like when you work with Travis CI, the Composer file can get out of date. So I know with all my projects, I think I include a line in my Travis configuration to do the Composer self-update. So I added that same type of thing to my Elastic Beanstalk application, and then it worked fine after that. So that's something you might need to do. And the way you do that is using EB extensions. So Elastic Beanstalk has a way that you can run any arbitrary commands when your application is deployed. So this allows you to do custom things like run artisan scripts, do migrations, and things like that. And I use the same thing to run Composer self-update. So the way you do it is you create a .eb extensions folder, and then you add a config file. And basically, it doesn't matter what your config file is called, but they are executed in lexicographical order. So I just started mine with 01 so that it gets run early. And then I use the Composer self-update command in there to run that. And after that, everything deployed fine. And this is basically what we end up with, architecturally wise. So we have our Elastic Beanstalk environment, which I told you includes EC2, Elastic Load Balancer, and auto-scaling. But it manages all that for you. So the user interfaces directly with the load balancer. And then our EC2 application uses both S3 and DynamoDB to store information about the funny faces. And that's basically how it works there, using multiple AWS services. And what's cool is the Elastic Beanstalk environment, you can set it up so that it auto-scales to multiple servers if needed. So you can set traffic thresholds like, once I get to 80% CPU utilization, add another server. Or, and then you can set it so I want at least 2 servers, no more than 5, and then it will auto-scale up and down for you automatically. All right, so that was the basic application, and I got that running. I didn't have time to work on other stuff, but I definitely have ideas of what I would do, so I wanted to talk about that. So first thing I would probably do is add in another AWS service called Route 53. That is our DNS service, and that allows you to basically take your domain names and route them to EC2 instances or load balancers or other AWS servers that you've set up. So I'd stick that in there so that the user can use a domain name to get to your Elastic Beanstalk application, because otherwise, they have to memorize a pretty weird URL to get there. But that's good when you're in testing. You don't want them to go there while you're testing. Another service that AWS provides is CloudFront, which is our CDN service. Who's using CloudFront with anything right now? Awesome. So CloudFront, I think, is an amazing service, which allows you to distribute your content globally and in a way that's cached, so that your, especially media and other files, can be, have a low latency between your users and your content. And you can also set it up to do things like streaming video and other things. So I could use CloudFront service, create a distribution in front of my S3 bucket, so that those funny face images are cached globally around the world and easy and are fast to view in the browser. So with my simple application, basically, I made some assumptions about, that I'm the only one using this right now, and the images that I upload are going to be a certain size and don't require any processing. But of course, that's not a real-world case. If any of you have done any type of application where people upload like a profile picture, any kind of photos, they're almost never in the format or size that you want for your application. You have to do some kind of processing on them. If you, in your application, you're doing that processing right as they're uploaded, that can take a lot of extra time to do, depending on the size of the picture. Like if they upload a 50 megabyte picture that you have to resize and crop down to something, that can take some time to process. So one thing I would do for this app is actually use SQS to push that task onto a queue, and so that I can have worker nodes do that in the background. And as I was saying earlier, Laravel already provides a queuing abstraction that hooks into SQS. So you can do something like this code snippet here to create a job on the queue and put in information about the picture that was uploaded, so that you can create a task that will pull from the queue, process the image, and handle it that way. To configure Laravel to use SQS is pretty easy. There's a queue, app config queue PHP file already in the standard Laravel installation. And you can go in there and configure your connection to use the SQS driver, and then you have to put in your queue URL, which you get when you create the queue from on the AWS console or through the API. And then you also need to specify the region. With every client that you use in the SDK, you need to specify the region, except for a few that are global in nature, like IAM and S3. So, and also in the standard Laravel config file, there's also a place for your key and secret, for your credentials. And so I've removed that because I'm relying on that credentials file still. The SDK will automatically pick up that credentials file if you don't specify any credentials manually. And again, that's in the newest version. So if you want to use that feature, you need to update your copy of the SDK. So if we use this the SQS system to handle these images, we could set up an architecture that looks more like this, which is a tad bit more complicated, but it has the benefit of being able to process those images out of band and make your website faster. In fact, you can set up another Elastic Beanstalk application that acts as a worker application just for processing those images, and hook that up to SQS. And there's actually, in Elastic Beanstalk, there is a type of worker application that you can create. And there's a lot of documentation about that on the AWS website. So if you are doing background tasks and you have a need to have your background processing logic be able to scale, that is a really cool option that you could look into, is using Elastic Beanstalk for your worker nodes. So there we go. We have an application running on AWS. The application itself is simple, but we've created it and architected it in a way that it's very scalable and could support many, many, many concurrent users and scale up to more. And that's pretty cool. And that's really the purpose of all this cloud computing stuff, is to make it easier for you to produce applications that scale to meet up the load that supports your business. So that is actually all I have for you today. I will be posting these slides on JoinedIn, and it'd be great if you could leave some feedback there for me. And then I have the hashtags there and also the Twitter account there. But I'd love to take any questions that you have. So thanks. Oh, and I was going to say, I brought with me a bunch of AWS stickers, and I also have some AWS credits to give out too. So if you want either of those things, come talk to me at some point, and I have them with me, and I can give them to you. But any questions? I can't see very well. Here we go.
Yeah. So in the beginning of the talk, you had a call run instances.
Yes.
When you call that, and when you set like minimum count to 1 and maximum count to 5, would it automatically create a load balancer for that one?
Okay, so the question is, when I showed that EC2 run instances command, it had a min and max count parameters. And basically what those do is you can say, what you put as a max count is how many you want, and the min count is how many you can live with. So in some cases, you might be up against like your specific account limitations, or maybe some limitations within that geographic region that you specified. And so the request will fail if it can't produce at least the min count, but it will do the max count if it can. And that's not the same thing as autoscaling. So autoscaling is a different API, and you would have to add those instances to your autoscaling group using the autoscaling API. Right there.
What does the wait until method do on the background, like for example for buckets?
For example, what?
Wait until a bucket is created. What happens in the background?
Gotcha. Okay, so the question is, what does that wait until method, the waiter feature I was talking about, what does that actually do while it's waiting? So it basically has an interval that it'll sleep for, and that's configured for that particular operation based on what we think is a good number of seconds or microseconds to wait, and then it'll check again and do describe calls. So it'll do that a few times until it's ready. And you can actually customize the interval too if you want to. There's options you can append to that method.
So I guess there's a timeout that throws an exception.
Yes, yeah. So we don't let it wait forever. There's one of the parameters is called max attempts, and so we have those set by default for the specific operations on what we think will be good there. But you can also again override that too. Like if you only want it to check 3 times, and you're like after that I don't care.
Will you add a PHP Storm plugin for like for all the tools?
That would be cool.
Yeah, right.
I don't know, but I will bring it up with their team, because I mean not only PHP Storm but all JetBrains products basically. I mean there's.
So Elastic Beanstalk's big brother OpsWorks is still running PHP 5.3.
You know what? I bug them every week about that, just so you know. No, they are working on support for that right now. So I would not be surprised to see that sometime soon. So this question was, OpsWorks is another one, a service similar to Elastic Beanstalk, kind of takes a different approach and relies heavily on Chef So if you're interested in working with AWS that way, OpsWorks is another service to look into. But yeah, right now it only supports up to PHP 5.3, but they are working on updating that to support PHP 5.4 and 5.5. Cool. Any other questions? Oh, one more right here.
So you've got iterated reading for things like CloudWatch, where you can only send 20 metrics at a time. Is it iterated for sending as well?
No, we don't have anything for iterating. So you're saying, is there iterators for the setting side of things versus the getting side of things? No, there isn't anything for that. One in the back.
Do you happen to know anything about HIPAA compliance with all the various instances?
I don't know the specifics about it, but there is a section of the AWS website that talks about that. I think I'd probably start in aws.amazon.com/security. I believe that we do have HIPAA compliance. I'm not sure all the details about that, but there's
There is, and there is some information. It's a little bit high level, but that's fine.
Gotcha. Yeah, there's and. Gotcha, yeah. So AWS does try to go out and make sure that our services are compatible with those types of requirements, and we've gone out and got several different accreditations and compliances there, and so you can go on the AWS website and see what we've done in that regards. Cool, are we ready? All right, thank you.